Two Sigma Investments, LP is an American hedge fund headquartered in New York City. It uses a variety of technological methods, including artificial intelligence, machine learning, and distributed computing, for its trading strategies. The firm was run by John Overdeck and David Siegel until August 2024.
Founded in 2001, Two Sigma has become the very top quant fund in the world, whose performance is in the same league as Renaissance Technologies and D.E. Shaw.
Today, through the use of algorithms, with its unique culture, the firm manages over $52 billion in assets, with more than 1,400 employees across offices in New York, Hong Kong, and Tokyo.
Inside this Pizza Hut was the hedge fund legend Paul Tudor Jones. In there, he was having a confidential meeting with the managing director of D.E. Shaw, John Overdeck. Together, they envision a new type of quant fund that can compete head-on with Rentech and D.E. Shaw. Without hesitation, Paul Tudor Jones decided to provide a generous seed capital for the new hedge fund. They also invited David Siegel, who was the Chief Information Officer at Tudor's Investment Corporation, to join the team of this potentially groundbreaking hedge fund. Tudor Jones has strong confidence in both of them, confidence backed by their impressive resumes. The financial market is known to attract gamblers and risk takers, but it also attracts nerds who have a strong desire to make sense of this complex system. These math wizards try to understand the market by making a lot of money. John Overdeck is a Stanford-educated mathematician who was working alongside Jeff Bezos at D.E. Shaw. And yes, that Jeff Bezos, who runs a little company called Amazon. Siegel is just as impressive. He holds an artificial intelligence PhD from MIT and built a successful fintech company sold to Merrill Lynch. After that, he became the Chief Technology Officer at Tudor's Investment Corporation. But financial market is a highly complex game, where even quants with PhDs often failed miserably.
Well, our vision is really to focus on the capabilities of data science. And we think of investing as a data science problem.
From day one, they decided to differ themselves from other hedge funds. They consider Two Sigma to be a tech startup whose mission is to build technologies to extract signals in the financial market.
We think that by incorporating more and more information on the world into making investment decisions, we can do a better job. This is nothing really, in a way, a new idea. Investors of all ages have wanted to use data in making their investment decisions. No investor would say that they're just waking up in the morning and randomly picking something to invest in. But the ability to basically incorporate huge information occurring around the world into every single investment decision that you make, that's only possible by using these advanced data science methods. And I think that even in the field of investing, we're still in the early days of what these kinds of methods can do.
You mentioned Drew Conway. That also reminded me of another kind of celebrity data scientist alongside yourself and Drew that I believe was until recently at Two Sigma, Wes McKinney.
Yeah.
And so he is, for people who aren't aware of him, you've almost certainly used his software because he is, and you can correct me if I'm wrong on this, but if I'm remembering correctly, the founder and primary contributor behind the Pandas library.
Absolutely.
Yeah.
So he actually interviewed me at Two Sigma when I was being interviewed to join Two Sigma. He left maybe a year ago, and I think he wanted to focus even more so on the open source development and extension of his software, and but he has been closely partnering, so we are still working with him, and we're using a lot of his developments, and even have like direct collaboration to the extent that we're looking for extensions that seem to be useful to us.
And I think this is public information. I'm pretty sure I read online that Two Sigma is an investor in his company that he started since leaving. Yeah, so
that
definitely
goes back to one of these kind of affiliate, like the venture business, that are really, given the understanding we have about where the technology stands in data science and what some of the kind of missing pieces might be, there's a very deliberate effort to identify those companies that could help building out these pieces. So I think it very well aligns with our strategy, despite the fact that we like Wes and that we are very happy to support him in his future endeavors.
Yeah, and I can speak to the venture side of Two Sigma being unusual in a really good way. In that, so Two Sigma has been a client of my company for many years now, and at one point we came in and talked to your venture arm. We were invited to come in based on what we were doing and have some further conversations, and it was amazing to me the level of interest in the models we were building. And we were talking about whiteboards, literally getting up at a whiteboard in a boardroom, the kinds of skills and tools that you use. So what kinds, you've mentioned now, you've discussed what your kind of work is, so you describe it as what you call the front end R&D. So it isn't like front end development, it isn't like building a user interface, but it's the where in your world the back end is executing the trades. I suppose the front end is coming up with ideas for models that trades get executed on. So what kinds of tools do you use to do that?
So first off, there's a little bit of front-ending going on. So we do have a number of dashboards, especially for things like these COVID insights, also a lot of focus on election. So we have done a little bit, but that has not been my core focus. Right. I mean, you should not at all be surprised to find the kind of typical stack of data scientists, bread and butter. Obviously, a lot of work happens in Jupyter Notebooks. At this point, I think Python has become a very prevalent modeling environment. There are still, I find it fascinating, some of the tooling is kind of straddling the place between specifically built for the needs of the company, vis-a-vis then having the kind of open source tools and kind of the flux in between. And depending on where you're ending up, as you get to the more Two Sigma specific things, then the support you need and what kind of help on that side is kind of very specific. But in broad terms, in terms of tooling, we are utilizing cloud for a number of data storage and even processing. As I said, Python is the primary use case, or primary language. You have a lot of Spark going on for some of the more intensive scaling challenges that people deal with. There is I think that's an open source tool called IBIS, which is used to basically interface with any kind of cloud storage system. So it automatically generates SQL queries from a more kind of programming language that many of the coders feel more comfortable expressing their data manipulation in that format, and then have it auto-generate the SQL that you can.
I didn't know about that.
So I think that's broadly speaking where most of, I would say 95% of what I call front end. Now, truth is, we have folks that write code in R. If you're really good at R, if you want to do your research in R, go for it. So it's not very prescriptive on the ideation side. I think once you get more into the productionalizing it and making sure this runs then on the schedule and so on, I think there's a lot more consistency and requirement. But on the R&D side, I've written the occasional Perl script. Not that that's something that I would recommend anybody to do, but okay, never mind.
And one thing that, if I recall correctly, I mean, I don't know, maybe I don't know if people would find this interesting or not, but most organizations, they're a Windows organization, or if you're a tech startup, you'll often be a Mac focused kind of organization. But if I recall correctly, everybody's working on Ubuntu. Is that right? Am I misremembering that? I thought for some reason.
So I don't. Let me tell you what I work on. When I joined, and then you can draw conclusions from there. When I joined Two Sigma, we were just in the process of moving, allowing people to work on laptops. And that was, from a security perspective, a significant concerns, because now you're moving with this. You could be sitting in a coffee shop. So the concerns of security around the potential of having proprietary confidential information. And by the way, this is not just because we want to be secretive. I mean, there's a lot of regulation and around what we should and shouldn't be doing, right? So it serves more than just a let's kind of contain our ideas. And so at that point, we now started to being able to work on Windows-based machines, laptops that we could open up.
I see.
So the venture team is on MacBooks, but most of Two Sigma embraced laptops, and the timing was really excellent because by the time remote work became a necessity, pretty much everybody had a laptop.
Right.
Otherwise, people had at home maybe a workstation that mirrored the workstation they had. They were also Windows-based, by the way, so you would still log into a Windows system. The actual compute, a lot of that happens on cloud machines that you log into remotely. And whether you now just go in kind of behind and open up a notebook on your, or whether you actually go in there with a full X terminal, kind of a full view, I think that's a matter of taste. So yes, most of the compute is clearly on Linux. And I have no idea if it's Ubuntu or not.
So when you're looking to hire, Two Sigma is hiring the most talented people on the planet. What do you look for in terms of hard skills or soft skills?
So I want to give you kind of a broader sense. I think there is Two Sigma hiring at large, and then there is the more specific need that I feel I have for my team. And there's a little bit of a difference. There's the constant balance between good financial understanding and being able to have like hypotheses about economic factors and drivers. And on the other side is diversity of thought, that when you do get to a whiteboard, you really have somebody who can challenge you and can bring very different kind of orthogonal thoughts. If we're all thinking the same thing, then that signal really doesn't give you any way of managing risk or anything. So there is very strong emphasis in getting diversity of thought and hypotheses. And we're measuring how kind of different your ideas are once we get to a point where we're having the signals. So in that search, there's this balance between how much background and what kind of background do you require in these different areas. One thing for sure, we are a technology company. So I think once you are on the modeling side, you have to be able to code on some level and be able to do data analysis. So in the more executive, like if we're looking for advisors on certain roles, that's not like once you're reaching a certain level, but let's talk about normal hiring in terms of skill set. Compute is definitely necessary. And then in terms of background, I personally have really tried to find the non-usual suspects. So people with background in library science or your pure econ, or Drew himself came from social sciences. So I personally have found kind of that mixture to be really interesting and make for great conversations and great innovation. At the current moment, I feel that I've gone so far out of my way with that strategy that I probably should hire somebody who knows more about finance than I do. So in terms of really then connecting your hypothesis to how it would affect markets, that piece. So it's really you're looking for these missing building blocks. And so when you are talking to the HR team, I'm trying to describe to them as clearly as what I'm looking for. And then often we're discussing, well, where do you think these kind of people are working right now? And what kind of background should we be looking for? So it's actually a very closely involved relationship that we have with our HR teams as we're describing who we want. And then even, I really want these type of people on my lineup to talk to that person, because actually I can get help if the Python programming isn't really up to par yet fully. I can get somebody to mentor that. That's something we can absorb right now, but we're really looking for that skill to complete our team's skill set ultimately. So
Right.
this has been, it's not like cookie cutter, you go out there and then they're coming in. There is a good amount of involvement and thoughtfulness in terms of what skills would complement the team that we have.
I want to kind of understand, like, how maybe even like a day in the life of like a feature forecaster. Like, how do you go about the role? Or how do you think about the, prototypical, workflow that you're working on?
Ultimately, our goal is to find data and features and predictions in as many places as we can, right? So what does a day in the life look like? I don't know. You're walking by a Target and you see a help wanted sign in the window, and then you say, oh, I didn't know they're hiring here. They're interesting. That's growing. And then you say, oh, well, maybe that means they're doing well. And then you say, oh, well, can I measure employee hiring across all companies that we trade? Well, how would I do that? Okay. And you do a bunch of sort of, and then following this sort of inquisitive detective style work until you might say, okay, hey, look, companies post job postings on their websites. So I can start to collect that data. And if I can analyze it, I can start to create features about open roles for every company. Once I do that, it's not that complicated to think about, all right, I have all this data. What are some hypotheses that might come out of hiring? Is there an increase in hiring seasonally since last year? Do we see this movement? And what we tend to do is start with a hypothesis. We test that hypothesis by essentially collecting data historically. So not only do I need the job, this is the hard part. Not only do I need the job postings there today, but in theory, I need historical views of those job postings. And so let's pretend for a second that I have 20 years of companies' job postings, which is hard to build, but let's just give me that. Then what I can do is I can go back in time. And for every day, I can see what the world looked like on that day. And I can use it to see what happened to that company over the next week, month, year, whatever. And so I can test my hypothesis. Hey, is it true that an increase in job postings leads to an increase in share price? And it's just a scientific statistical test. If the answer is yes, maybe I'm going to end up using that as a trading signal eventually and build what we call a model, which is basically something that takes data in and makes predictions about future prices of the assets we trade. And that 20-year, I can't stress enough, where do you find 20 years of history on a company's website? That is the interesting, challenging part about this work, is timestamps are so crucial. We typically, in order to get 20 years of data, a lot of the time you have to say, okay, let me start recording this and I'll come back to it 20 years later, which is a very forward
So in 3 years, you'll be able to do your job.
Right. Right. Exactly. So, obviously 20 years is a big, but maybe there are many things that I've been recording for 5, 6, 7, 8, 10 years that we're now able to do, or even 15, right? So you have to have, people used to ask me, hey, what data should you be recording? What should we record? And the answer was always anything that might be interesting in the future. I don't care if it's interesting now. It's like, this is a time capsule. If you hit record today, this is a gift to either you in the future or another researcher at the firm who's going to suddenly have this rich history of data to then go and study. Because if you don't have that historical data, a lot of data just disappears like forever. There's no recording of it. There's a great example, which is we worked with a newswire, and they would send us news stories about companies. And one day we get this call, hey, I heard you have a recording of our news. Can we buy that from you? Because a news company, they don't mind rewriting their headlines. They don't mind changing, adding little topics, editing. And so they don't actually know at noon on this day what they actually had sent. So at Two Sigma, we're an investment manager, and ultimately we're trying to invest in instruments that we trade. And to do that, we want to predict the future price of things, right? So to do that, we have to kind of, whether it's a company or a currency, right? We have to understand a lot of information about, say, a stock, let's say, IBM, and use all that information to make predictions about the value of that company. And to do that, we think of this breaking down. We think of breaking down the world into features, where a feature is just sort of a interesting, observable fact of interest about something. We have philosophical debates about what is a feature, and so the idea is that for a company like IBM, there are thousands, tens of thousands, maybe millions of features that might tell you about it, right? It's sales numbers, the number of computers, the people who work there, where they came from, the board, the stock market prices. And for each of those, if we can quantify them, if we can measure them and record them, then we can use them to predict what happens next. And so this idea of feature forecasting is to make a lot of interesting features about the world and then use those features to forecast about what's going to happen in the world.
So this reminds me of I don't remember when we started doing this, but we, the royal we, I guess, but like we're going to take satellite imagery as it passes over Walmart and count the number of cars in the parking lot and use that to predict share price, that kind of thing. That would be an example of a feature, which is like
the number of cars in the parking lot at any given hour would be a feature for sure, right? That's a very interesting feature you could get from a satellite image. That's a great example. Ultimately, our goal is to make predictions about where, say, stocks are going. So if I'm looking at news stories about a company and I want to make predictions about what that means for that company, right? I guess I have to build a bridge between that news story and some algorithm that's going to make a prediction. And whereas in this one hot world that was there were methods, it is a much more rich world to be able to convert that story into an embedding or multiple embeddings, or there's different ways you could approach that. Once you're in this vector space, it becomes a much more natural connection into the machine learning world, right? If everything's a 300-dimensional vector instead of a blob of words, what comes downstream is and people can imagine is a various sophisticated learning algorithms that can try to tie the thing that you're embedding in whatever creative way you want to into a prediction about the world.
So it's kind of like you were saying before, like you alluded to, like same but different. It's like you are doing many of the same things, like sentiment you referenced, maybe related companies, related people, building knowledge graphs, all that kind of stuff. And now you just have a more powerful way of doing it that is semantically rich as opposed to based on word counts and that kind of thing.
It's more semantically rich. And so those vectors themselves could be features, right? You could make features about a company. You can make features about a story. You can make, so, and the LLM, I mean, under the hood, it's embedding things. And so if you have access to the internal workings, you can also pull the embedding right out of the process, depending on what the software is. Or you could take the output and, do what you embed that, right? You can do so many there's so many ways to interact. So I think the very simple way is, hey, LLM, give me the sentiment of this thing. And it gives 1 through 10. And like that, I could do that. That's very straightforward now. That wouldn't have been straightforward, obviously, years ago. But that's the thing about financial modeling, is that it is so incredibly noisy, right? In machine learning, I think people don't fully think about the fact that in most machine learning tasks, there is an answer that you could get given the information you have. So if I had to say, hey, is this a cat or a dog? You could figure out the answer. Usually, hey, what should I do in this car? Should I slow down or speed up? there's usually a good answer. There might be like something crazy happen, so not always. But in finance, you actually it's not clear that no matter how much information you have, that there is enough information to predict with any real certainty what's going to happen tomorrow, right? And so we're making this prediction into the future, which means that the signal to noise ratio, the noise is just so much bigger, right? And so if we can predict an R squared, and if you see an R squared of like 0.05, you know something's broken because that's way too high. Like, like there's no, these things that you're trying to predict are very small signals, right? The nose touching might be real, but it's not going to be predicting most of that stock price. It's going to be a tiny portion. And so, yeah, that's one of the challenges of the financial markets. And I mean, it has to do with your priors on how important a particular build is, like how fast you need to get it out. And if you think that you're in a position where you have an edge to utilize that novel thing you're doing, and especially in an industry like finance and quantitative finance, where you're literally competing for prices, like it's someone else's machine learning is against your machine learning, and it's a zero-sum game, right? So time matters. If you're 6 months out the gate before the other group, that means that can make a big difference, because what you find, by the way, is when you trade signals over time, they get weaker and weaker and weaker as your competition starts to come in, and so it's called alpha.
It's kind of efficient market.
Yeah, it's an efficient market, right? Any innovation you think you have, well, now everyone has access to data X or Y, and so it slowly decays away over time. So there is a time component, and you have to. It comes back to that return on investment question and your priors as a researcher of how important that particular thing is to get now versus later.